Okay, folks, let's look at this beastly question where we are asked to solve algebraically the simultaneous equations x squared plus y squared equals 25, y minus 3x equals 13. Okay, so this is quite a big and beastly 5-mark question. Okay, it's not too bad of a question. Obviously, it's not easy, but once you follow my steps here, okay, this will apply to all the quadratic simultaneous equations, okay, in this format. So I've got an equation. You have a circle, so I'm going to label that as equation 1, and I'm going to label this here as equation 2. So I've got a circle and a straight line here, and we're looking for the point of intersection. So step 1 is I'm going to rearrange the second equation to make y the subject. So I'm going to add 3x to both sides. So that'll be y is equal to 13 plus 3x, or 3x plus 13. Okay, I'm now going to substitute this into my first equation where I've got the y squared. Okay, so I'm going to have x squared, okay, plus, now in brackets, 13 plus 3x all squared. Okay, is equal to 25. Okay, so all I've done so far is rearrange the second equation to make y the subject and then substitute it into the first one. So replace y with 13 plus 3x. I'm now going to expand this double bracket. Remember that squared means times it by itself. So we're going to have x squared. Then we're going to have plus. Now I'm going to have in brackets 13 plus 3x multiplied by 13 plus 3x. Okay. And because it's going to be a quadratic, okay, I'm going to close the brackets here, and then I'm going to bring the minus, I'm going to bring this 25 over to the left-hand side. So I'm going to subtract 25, and then it's going to be equal to 0, okay? I'm now going to expand and then collect my like terms. So I'm going to have x squared plus, so I'm going to have 13 times 13, which is 169, okay? 13 times 3x makes 39x. Okay, 3x times 13 makes another 39x. Okay, then we have 3x times 3x makes 9x squared. Okay, and I'm going to take away 25 and make it equal to 0. Okay, now I'm going to collect my like terms. So I'm going to have a quadratic. So we got x squared plus 9x squared. That makes 10 lots of x squared in total. So we're going to have 10x squared. Okay, what next? We've got 39x plus 39x. That's going to be plus 78x. Okay, and then we got 169, and we're subtracting 25. We get plus 144. Okay, again, obviously pause it and check my mental maths here at any stage. Okay, by doing the column method. If you're unsure, next step here is because they are all even numbers, I'm going to factor out a 2. So I'm going to have 2 brackets 5x squared plus 39x plus 72, okay, is equal to 0. Okay, and now I'm going to do this here by trial and error, okay, because I've got a non-monic quadratic, okay. So I'm going to have 5x here, and then I'm going to have an x here if it does factorize, okay. Sorry, I haven't got much extra space, I apologize. Okay, so factors of 72, we're going to have 1 and 72, okay, so that isn't going to work. We're going to have 2 and 39, that also isn't going to work. We're going to have 3 and 24, that might work, in fact, it does work, yes. So we're going to have plus 3 here, and then plus 24, okay. This bracket here obviously is going to be equal to 0 just to make it clear. So this is equal to 0. Again, sorry about lack of spacing. Let's bring this down. So either the first bracket is going to be equal to 0. So either x equals minus 24 fifths when I set the first bracket equal to 0, or x equals minus 3, okay, for your second bracket, okay, to be 0, okay. Right, what's next? Well, I'm going to sub these into a cut value of y, okay. So y is going to be equal to, now let's go for minus 3 here first because it's a bit easier. So 3 times minus 3 makes minus 9. 13 plus minus 9 is 13 minus 9, which is going to be 4. And then when I have minus 24 fifths here, it's going to be a bit more trickier. We're going to have 13 plus 3 lots of minus 24 fifths. Okay. This is not as obvious here. It's a bit more trickier. Okay. That's going to be what? That's going to be 13. And I'm going to be minusing 72 fifths. Right? Now 13 is 65 fifths. Okay, so 65 fifths subtract 72 fifths. What's that going to give us? Well, that would be minus 5, so it'd be minus 8. Is that right? No, sorry, minus 7. Sorry, I apologise. So yeah, minus 7 fifths. Okay, let me just double check here. So let me just do 72 here. Sorry, for some reason I can't do that in my head. I don't know why. I mean, I can do the other calculation in my head, but this one, for some reason, I keep making a mistake. So I'm going to borrow from there. 12 take 5, yeah, 7. Yeah, that's it. Sorry, I was double checking. So minus 7 fifths. Okay. And that, guys, is my solution to this quadratic simultaneous equations question worth 5 marks. X equals minus 24 fifths. Y is minus 7 fifths. And x equals minus 3 and y is equal to 4, okay? So they will be your points of intersection of the circle with the straight line. Okay, a very tricky question again. I'm not going to say it was easy, but a lot of it is down to your algebra. See, if your algebra is strong, okay, and your mental maths is strong, okay, then there's no reason here why you can't get 5 marks. But again, please do obviously practice these grade 9 questions, okay. They're not too bad once you get into the thick of it, okay. All we do normally is we rearrange the linear term or linear equation one, okay, in the form y equals mx plus c, or x equals a function of y, and we sub that into our quadratic equation here, whether it's a circle, a quadratic, maybe even a cubic, okay. Although a cubic probably isn't GC level, but a quadratic or a circle, okay. Rearrange it, okay, expand and simplify, factorize, sub in, and there you go, okay. And that will be a nice 5 marks to get in your exam. Okay, honestly, if I saw this here in the exam next year, I'd be well happy. I'd be like, yeah, that's a nice 5 marks to get, okay, out of 80, okay, on a paper, which is going to obviously help you get those top grades in the exam and help you achieve that grade 6, grade 7, grade 8, and grade 9 for GCSE maths. Okay, thank you for watching.